The standard solution for strong and stiff composite sandwich parts is the coring with foam lightwood panels like balsa or honeycomb. Based on special requirements concerning strength, cost, specific gravity, etc., there has been no serious alternative to these kinds of core materials until now. According to big improvements in many industrial and technical application fields, even in the boat industry, it is surprising that the sandwich technology for composite boats is still at a similar level as decades ago. Same types of core materials used 40 or 50 years ago are still dominating composite sandwich constructions in the boat industry. We think that sphere core SBC could be a higher sophisticated alternative. Why? To give an answer to this question, let us take a trip into the past and into the future. Classic sandwich constructions which did a great job for many decades can now partly be replaced by better solutions. It's now possible to improve long-term durability, physical parameters, laminate homogeneity, water resistance, processing, and cost savings. The function of a sandwich construction is completely dependent upon an absolutely faultless bonding of the covering layers to the core layer. Any defect in this bonding caused by processing mistakes or use stresses completely destroys or limits this function. Exactly this is the weak point of all classic sandwich constructions, as all core layers like balsa, foam, or honeycomb have a totally different physical structure than the covering composite layers. With sphere core SBC, it is now for the first time ever possible to produce composite parts with a perfect laminate homogeneity, the structure of an all-glass laminate, and the characteristic of a classic sandwich construction. Using sphere core SBC instead of balsa, foam, or honeycomb means a remarkable improvement in nearly all physical and quality parameters. Furthermore, the processing procedure is much easier and more cost-effective. Unexpanded thermoplastic microballoons are embedded into the basic glass ply. By a thermal process, the microspheres are expanded to the desired thickness. This core layer, called sphere core S, must be compressed by a mechanical compression process and held under compression by a following stitch bonding process. The result is a mat called sphere core SBC, stitch bonding compressed, with a reduced resin absorption. The specific gravity of sphere core SBC is about 400 kilograms per cubic meter. After sphere core SBC has proved its superior technical and physical properties, it is now time to show the ease of use and how the sandwiching of composites can achieve cost, labor, and waste savings. Please look at the following sequences. Even complicated parts don't need prefabricated kits. With scissors and a carpet knife, it is very easy to cut sphere core SBC. Unlike classic core materials like balsa, foam, or honeycomb, sphere core SBC must be impregnated with resin until saturation. Any oversaturation is not possible. This procedure can be carried out outside the mold by wetting out the material from both sides, or inside the mold by turning the SBC layer upside down. As sphere core SBC is a core layer, it has to be covered from both sides with covering layers of pure glass. The whole lamination process should be done in one shot to achieve a perfect laminate homogeneity. After the contact of sphere core SBC with the polyester resin, it achieves the consistency of a malleable paste, which can be shaped into the most complicated curves. The edges can be flattened down by a certain pressure of the de-aeration roller. Even overlapping is possible without any gap or joint. The use of sphere core SBC means a big step ahead by increasing productivity, cost reduction, and improving the physical parameters. Meanwhile, many big players in boat production are switching from classic core materials to sphere core SBC. The reproductivity of laminate constructions with sphere core SBC is very high, as the tolerances and the physical properties are very small. Unlike balsa, for instance, it is not necessary to implement high security reserves. The superiority of a sphere core SBC laminate becomes especially clear by comparing the compressive strength in comparison with classic core materials. The test shows that unlike the behavior of foam, balsa, or honeycomb, the compression properties of sphere core SBC are of the same character as those of an all-glass laminate. A characteristic difference to the behavior of classic core materials can be found by testing the impact strength. It shows that the material combination of high modulus fibers and the elasticity of microballoons gives sphere core SBC extreme energy absorbing properties. These fine companies are already using SphereTex. Sphere core SBC, the future in coring. SphereTex Germany is the only company in the world producing flat high modulus fibers based on e-glass, carbon or aramid, which are volumized with thermoplastic microballoons. These materials, known as SphereTex and Sphere Core, are used to manufacture lightweight composite parts that have high physical properties. Many large producers of composite parts around the world use SphereTex to solve their construction problems.